I'm Mr. Danny, and today we're going to talk about Newton's laws. Newton's first law states that any object that is in motion tends to stay in motion. Any object at rest tends to stay at rest unless acted upon by an unbalanced force. So, our first example of this is this ball. This ball is at rest, it'll stay at rest. It will not move unless it is acted upon by some force. Whether someone comes in the door and knocks it over, if I hit the table and it starts moving a little bit, or I can just hit it. Alright, that's an unbalanced force, it's my baseball bat. Alright, once I acted upon it with my unbalanced force, it moved and it stayed in motion until it hit the wall, and now it's back over here, and now it stopped again. That's inertia. Inertia is the tendency of mass to resist change. That's the exact thing it says. All right? So when you're driving in a car, and all of a sudden whoever you're with just slams on the brake, your body goes forward, right? And that is because of this law. Your body wants to stay in motion. All right? It wants to keep going at that speed, but then all of a sudden it's acted upon by an unbalanced force, so you shoot forward because your body wants to keep going. Now, I have two videos to show you, and in it shows inertia. Hope you enjoy. Alright, in that video, it showed me running, and I wasn't being stopped at all. My body just wanted to keep going. But then after that, I put up a board, and I hit it, and that stopped, and it hurt quite a bit. I messed up my hand. But it's prevented me from going forward. I was acted upon by an unbalanced force, which stopped me and made me fall over. That board is the unbalanced force there. If that board was there, I would have just kept running until I hit something else. Or until I would have slowed down because I'm very out of shape. Here's another video for you.
Hey,
Don't do that.
all right.
That ball was the mass coming at my head, and my head was the unbalanced force it hit, and it bounced off. Right? If that ball had more force, it would have actually taken off my head and just kept going. But it didn't. So the inertia of the ball hit my head, right? My head was the unbalanced force, hit it, and then bounced back. And that is basically inertia, and that's the first law of Newton's laws. So an object at rest tends to stay at rest, an object in motion tends to stay in motion unless acted upon by an unbalanced force. Newton's second law is the one that is force equals your mass times your acceleration. Mass and acceleration are inversely proportional. This one is just basically, I always say just force equals mass times acceleration. So what that means is, if I'm throwing a pen, I can throw that further than if I try to throw this table. Right? So, the pen I got across the room. The table I can only flip it once. So your force equals mass times acceleration. So the bigger something is, the less acceleration you can get on it. Or the smaller something is, the more acceleration you can get to it. So they're inversely. So the smaller the mass, the more acceleration. The bigger the mass, the smaller the acceleration. Alright, so when I flipped the table, I'd use a little bit more force because the mass was greater. But it didn't accelerate like the pen I threw did. When I threw the pen, that accelerated very fast because the mass was slower. So I actually had to use less force. Alright, so now let me show you the math behind that. So let's say the pen weighs 5 kilograms. Probably not, but we'll say that anyways. This is just to show you the math behind it. Let's say I accelerated at 20 meters per second squared. Alright? So force equals your mass times your acceleration. So I put my mass in, and then my acceleration. So 5 times 20, so my force was 100 newtons to throw it over there. Alright? Now let me show you how and compare that to the tape. Right, so let's do the math behind that. So we said the pen went at 100 newtons of force to get it over there at the acceleration I did. So let's say the table is about 220 kilograms. All right. Now let's say it accelerated at what, about 3 meters per second, just about. So then 220 times 3 gives me my force. So 660 newtons of force. So even though this accelerated much faster, I didn't need as much force to get the pen over there. But I didn't have to accelerate the table. I couldn't accelerate the table as fast because I had used more force. So the smaller mass, the more faster I could accelerate it. The bigger mass, the slower I accelerated it, and it was a greater force. Now let me show you this one more way. So I have a ball here, and I have my small mass. This is a hammer, my kid's hammer. So I'm gonna hit this ball. I'll hit it over here, so you can watch it go. All right, and all I'm gonna do is turn my body back. All right, see how fast it went? It didn't go very fast. My mass is very small. Now I'm going to get a larger mass, and I'm going to accelerate the same, and you'll see it move just a little bit faster. Alright? If I keep the same acceleration, but my mass increases, it's going to go faster. Newton's third law. This is probably the hardest one for people to remember. It is the equal and opposite reaction. What it states is everything has an equal and opposite reaction. So if you lean against the wall is actually pushing back against you. It's when you overcome that the wall would actually fall over. That is also why when you punch a wall, your hand usually doesn't go through it if it's cement. Because what's happening is when you hit the wall is actually pushing back on your hand. If you punch the wall and you go through the wall when you punch it, that means you overcame it. But some of that force still went into your hand. It's still going to hurt. You're never going to punch a wall as hard as you can, and it's not going to hurt. It's just because of this equal and opposite reaction. All right, these are Newton's 3 laws, the basics of them. There will be another video that I'm going to go into some more examples about it. Hope you understand it, and good luck.